A quote from Stephen Hawking's steady-state theory was what Karl Popper would call a good scientific theory. It made unambiguous predictions that could be confirmed or disproved by observation. Unfortunately, it was disproved. Cambridge lecturers Fred Hoyle, Hermann Bondi and Thomas Gold spontaneously realized after a whimsical movie night that the universe must be eternal. The new theory has changed the way we think about the universe. Forever matter replaces matter. Time does not exist and the universe is in an eternal unchanging state. If Hoyle, Bondi and Gold are right, then what about the Big Bang, and more importantly, what movie inspired the three so much that they came up with one of the most debated theories of the 20th century? What are 330-something Cambridge astronomy and astrophysics lecturers doing on a Saturday night? No, they're not talking about stellar masses or galactic nebulae. They're watching a horror movie. It was 1945 and Dead of Night was all the rage in the cinemas. The British horror film consists of several interconnected short stories that are embedded in an interesting frame story. Dead of Night begins with an architect named Walter Craig who is invited to a remote country house. There he meets a group of people he doesn't actually know, and yet the people seem strangely familiar to him. One by one each of them tells an eerie story that they had experienced. The stories all involve supernatural events, such as ghostly apparitions, an eerie mirror, a cursed golfer and a creepy ventriloquist dummy. The frame story connects these stories and ends with a surprising twist. Walter Craig realizes why he somehow knows all this. He realizes that he has experienced all these stories before in his dreams. He realizes that the whole event, the meeting at the country house and the telling of the stories, is part of a dream he has been having over and over again. So he has been dreaming the whole time, and the ghost stories that were told are part of this dream. When he comes to this realization, it turns out that all the spooky events and encounters didn't happen in reality. The end of the movie shows Craig waking up from the dream and reality presenting itself as normal again. Still, it remains an interesting story because the movie makes it clear how dreams and reality can blur together, just as the audience couldn't tell whether what they were experiencing was real or just a product of their imagination. The same could happen to us. The plot of the film also leaves open the question of whether the events in the country house actually represent another level of reality. So what did this movie trigger in the three lecturers from Cambridge? After watching the movie, all three men independently had the strange feeling that there was more truth in the movie than they thought. They had spontaneous visions of an infinite universe and everything seemed totally logical to them. In the months that followed, they developed a model to explain the universe that we now know as the steady-state theory. Steady-state, a universe without change. It sounds crazy that a horror movie of all things inspired three top scientists to come up with one of the most discussed theories of the 20th century. After experiencing the movie, the three were certain that older theories were correct, according to which the universe is maintained by a constant flow of matter and that our universe may not be the only dimension. Such ideas emerged as early as 1918 when the American physicist William Macmillan suggested that new matter is constantly being created within the universe and that the universe is thus kept in a stable state. In the 1920s, James Jeans suggested that this matter is created in spiral nebulae and actually originates from other dimensions. Even Albert Einstein briefly took up the idea, publishing a manuscript in 1931 in which he described the idea that the universe expands through a continuously evolving stream of matter. However, physics then developed in a different direction thanks to the work of Hubble and LT. The idea of the Big Bang and expansion in time and space became established in 1948. Fred Hoyle, Hermann Bondi and Thomas Gold proposed what is probably the strongest counter-theory to the Big Bang model, the steady-state universe. This theory states that the universe has neither a beginning nor an end and that new matter is created continuously. The expansion could therefore be an optical illusion, triggered by the flow of matter as we know today. Excess matter is sucked out of the universe by black holes, for example, and possibly channeled from there back into other dimensions where it is renewed. In the 1950s and 60s, the steady-state theory was discussed by many scientists, and for a while it competed with the Big Bang theory for supremacy in cosmology. Has the theory really been disproved? Let's take up the quote from Stephen Hawking. He said about the steady-state theory, steady-state theory was what Karl Popper would call a good scientific theory. It made unambiguous predictions that could be confirmed or disproved by observation. Unfortunately, it was disproved. Hawking saw the theory as disproved. This was due to observations made by scientists from the 1960s onwards. But before we turn our attention to these discoveries, let's take a look at who the Karl Popper mentioned in the quote was. Popper was an Austro-Hungarian philosopher and mathematician, and one of the great thinkers of the 20th century. He said quite correctly that scientific theories can never be definitively proven but only refuted in plain language. This means that scientific theories remain theories until they are replaced by truths or they are disproved. Then there is a counter-theory that tries to prove something else. Nevertheless, they remain theories. This is precisely the problem our science is currently facing. The house of cards of its theories is collapsing due to real observations. The problem is still that the observations are far from providing us with the truth only when all the theories fit together seamlessly, complement each other harmoniously, and lead to what Albert Einstein called the unified field equation. Can we assume that we have discovered the truth about the universe? But back to our three movie fans and their steady-state theory. In the 1960s, the steady-state theory was supposedly disproved by several observations. Radio-astronomical discoveries showed a higher number of radio sources and quasars at great distances, suggesting that the universe is not static but changing. In 1965, Rob Penis and Robert Wilson discovered the cosmic background radiation, which has since been regarded as a remnant of the Big Bang. This discovery provided strong evidence in favor of the Big Bang theory and contradicted the assumption of the steady-state theory that the universe has no temporal development. However, nothing was really proven here. It was just that there were strong theories that argued against the steady-state idea. If we look at the idea of a temporary and spatially infinite universe, this idea does not necessarily mean that there are no movements, developments and dynamics within this universe. The theory only says that the space in which this takes place is infinite in a certain way. You can think of it as a lake into which water flows in and out, in which there are dynamics and life, but the lake itself is eternal, a dimension outside of time and space. The idea is crazy that we may have gotten ourselves tangled up in a problem through a small error of perception. Some scientific theories suggest that time and space are illusions that lead to false scientific assumptions. But how can this be? Our senses and measuring instruments are designed to recognize and measure space and time, but if these dimensions are actually infinite, our perceptions and the theories derived from them could be misleading. This means that many scientific assumptions made on the basis of space and time may be mistaken. We are at a delicate threshold in science. The James Webb Space Telescope is an $11 billion project that was supposed to show us the first galaxies of the universe, but what do we see? Rows and rows of galaxies that are so highly developed and structures so gigantic that they could not possibly have existed in a universe that was just 200 to 300 million years old. Even a few scientists are currently willing to say it out loud and admit it. These discoveries suggest that the universe is far older than previously thought, or infinite. Science is often reluctant to move on. Many researchers have grown too fond of their old theories to abandon them now. It almost seems as if a group of old men are staunchly defending theories such as the Big Bang and expansion simply because they are afraid that everything they have believed in all their lives is wrong. But there are also others, young and open-minded researchers, who will welcome all new findings with curiosity and openness. After all, science is not about being right, but about the truth. What if the steady-state theory is right after all? What hardly anyone knows at the moment is that the cosmic microwave background has also long been doubted, not its existence but its origin and significance. Some saw the cosmic background radiation as an expansion that started from a single point. However, researchers have even found evidence of parallel universes in the radiation, and Sir Roger Penrose used the patterns of the radiation to support his idea of a cyclical universe. This shows that radiation provides scope for many interpretations and points of view. The radiation could also have to do with the ongoing flow of matter, and this flow could in turn explain why the universe appears increasingly inhomogeneous on a large scale, which should not actually be the case if new matter is constantly being created. This could help explain irregularities in the distribution of matter in the universe. This inhomogeneity is one of the greatest mysteries of modern research. If the Big Bang theory is correct, the universe should be uniform, homogeneous and isotropic, but the Webb telescope shows us that this is not true. Some modern theories of quantum gravity, such as loop quantum gravity, suggest that space and time could be quantized. Quanta are known to exist in multiple places and at multiple times simultaneously, as they are the building blocks of our world. This could be a crucial clue that space and time are not as fixed as we think. If we take this thread further, we inevitably end up with the multiverse, and this is already as good as proven at quantum-level. Theories that propose the existence of many universes are partly compatible with the steady-state theory in a multiverse. Our universe could be one of many bubbles that constantly appear and disappear, which could reflect a continuous state of being. This would support the idea that there is no final creation but an eternal cycle of universes. Click on subscribe now, and look forward to many new exciting videos.